In today's video, we're going to be taking a look at the point-biserial correlation coefficient in Python. We're going to use libraries like NumPy, Scipy, and Python Pandas to jump through three different examples. The first one is going to be a manual calculation. The second one is going to be a super quick shortcut with Scipy. And the last one is going to be taking a look at a Pandas DataFrame. But before we jump into the Python coding side of things, I want to go over a little bit more about this special case of a Pearson correlation coefficient. All right, so a little bit more information about the point-biserial correlation. So this is a special case of the Pearson correlation where we understand the relationship between a binary outcome, think of like a pass or fail, and then a continuous metric. You'll see that this binary outcome is often called a dichotomous variable. And our final point-biserial correlation will range between -1 and 1. So like some of the other correlation videos, right? 1 is a perfect positive correlation, 0 means no correlation, and -1 is perfect negative correlation. If you have value between 0 and 0.1 or correlation 0.1, 0.3 low, 0.3, 0.5 medium, 0.5 to 0.7 high, and then 0.7 to 1, you're going to have a very high correlation. So here's how we can calculate the point-biserial correlation. Number 1, calculate the group means. 2, calculate the standard deviation of the continuous variable. And then number 3 is use this formula over here to the right and the different data points in this formula. So x1 is the mean of the continuous variables for the group where the binary value is 1. x0 is the mean of the continuous variable of the group when the binary value is 0. S of x is the standard deviation of the continuous variable. N1 and N0 are the number of observations where the binary variable is 1 and 0. And then N is the total number of observations. So let's take a look at this example over here. Let's say we have 8 different runners, and then we have our binary variable over here, which takes a look at if they finished a race or not. In this example, let's say they were running a 100-mile ultramarathon, and then our last column is the total running miles per week, which is going to be your continuous variable. So looking over here, there's going to be 4 runners that finish this race and 4 that have not, which is pretty typical for a 100-miler, right? About 50% completion rate. And then the miles over here, you have some people that are kind of low on the 50 to 60 range. And then you start getting the high mileage once you go over 100, although I've never ran over 100 miles in 1 week. So let's take a look at how we do this, right? So calculate the group means and N. So runners who finished, right? 110, 120, 130, and 90 miles. So N1 is 4, and then 450 divided by 4 is 1 at 12.5. Runners who did not finish 60, 70, 55, and 50. 0 is going to be 4, and then we have 58.75 for X0. So now what we want to do is calculate the mean of all the runners, which is going to be 85.6. Then calculate the standard deviation, which is going to be 31.38. And then finally, let's put together this formula, right? So x1 minus x0, we're going to get 53.75. Divide by the standard deviation, 1.713. Find n1 times n0, 16. Then n1 minus 1, 56. Then you plug everything into the formula, and you get 0.916. So the point-biserial correlation coefficient is approximately 0.916 in this case. This is strong positive correlation indicating the more miles a runner logs per week, the more likely they are to finish a 100-mile ultra marathon. So with this context out of the way, I think we are ready to start coding. So make sure to load up your notebook and we'll get started on the Python side of this tutorial. All right, so let's get started. What we're going to bring in is all of our dependencies. So we're going to import in NumPy, Scipy, as well as Pandas. So import NumPy as NP, import Pandas as PD, and lastly from Scipy.stats, import in point-biserial R, and that should be the only imports that we need in this video. And let's get started. So we're going to look through example number 1 over here. So let's start off with our binary variable. And we're going to say this is an np.array. I'm going to pass in what I used over here. Feel free to replicate exactly. If not, it's not a big deal. But 1 0 1 1 0 1 0 1 0 0. And then we're going to set up a continuous variable. right? And we'll say equals np.array. Inside over here, I'm just gonna pass in my other numbers. And this is just practice, so feel free to change up the numbers. If you want to copy what I have, 85, 70, 90, 95, 60, 88, 55, 93, 58, and 65. All right. Okay, and now we want to find the means of the binary variables. So we're going to look at the means of everything that's 1, and then the means of everything that is 0. So what we'll say is mean 1 equals np.mean, and then we'll have over here continuous var. Inside over here, we'll say binary var equals 1, and then we'll have mean 0, and we'll do the opposite where binary var is 0. So that's awesome. Okay, so means when we're having 1, means when we're having 0. Now what we're going to do is find the standard deviation of the continuous variable. So pretty easy there. So we'll say std x equals np.std, and then pass in our continuous variable. Right, and then make sure DDOF equals 1. And let me make a few new lines and zoom up. Or not zoom up, but scroll up. Okay. Now we need to find the sizes of each group. So n1 equals np.sum. We'll say binary variable equals 1. Now let's find our n0. And this is going to be when our binary variable is 0. And then let's find our general length. So n equals length. And you can just pass in binary variable again. Right. Oops. Sweet. And now let's plug everything into the formula. So we're going to say R B equals, and what we're going to do is mean 1 minus mean 0. This is all going to be divided by the deviation of x times np dot square root n1 times n0 divided by n times n minus 1. That should be correct. And let's print this out. So print over here, and I get 0.953. So we can also check if this is correct by using our Scipy example. So example 2, we're going to simplify this literally to one line. So we'll say Scipy, and all we have to do is rpb Scipy, and then we get a p-value as well. This video is not covering p-value. We'll cover that in another video. And then all you have to do over here is put your Point-Biserial, which I already have this over here, so I'm just going to copy that, and then pass in our binary, which we have over there, as well as our continuous variable. And have that for continuous here. And then all we need to do is print this out, and hopefully we have this the same, right? And yeah, 0.95366, 0.95366. So before I jump into the Python Pandas DataFrame, remember what we're going to do: manual calculation, you have binary and your continuous variable. And there's a lot of use cases where you have a binary or continuous. I didn't label these on the side of things, but right, we 1, 0, and then we have a lot of numbers over here. You can think of this as like miles per week. You can take a look at this as like first test score for a student studying data science in college, whatever, right? I always like using my miles per week. For ultra running, but regardless, right? We find the mean when this is 1, our binary variable. We find the mean down below when this is 0. Then we find the standard deviation of our continuous variable. And then what we do is we find the length when binary variable is 1, find the length binary variable is 0, find the length of everything together, which you could technically just added n1 and n0, and then just plug it into the formula that I showed you guys on the slides, and that gets our value. Or you can literally just go one line. But let's take a look at a Python pandas example now. So this will be our last example, and we'll go example 3, pandas. And let's build out our dictionary. So we're going to say data equals, and inside over here, we'll have our, let's say like miles per week. Let's say miles. And over here, let's have completed race. So go completed race. Inside over here, again, I'm just going to pass in our values that we had a little bit earlier. And then what we'll have next is miles per week. So miles per week. And you could just label these the same if you wanted to. But let's go with this completed race and miles per week. So we have is a dictionary. We need to create this into a data frame. So literally one line of code to do that. df equals pd.dataframe. Pass in our data. Nothing really too special with that line of code, but you'll see me doing that a lot. And now we have our df, so df.head. Just show you. Great. Completed race, miles per week. Awesome. So now we know that's working correctly. And literally all we have to do, I'm kidding not, this is cake. So RPV equals df. And inside over here, right, we're going to put in our miles per week. Well, actually, it's completed race. I apologize. And then inside over here, we'll say .corr. Then inside over here, df. And then grab miles per week. Right. And this should be the correct answer. Let's print this out. And I should have said RPB pandas. I did not copy that over correctly, so I apologize on that. And let's print this out. So RPB pandas, we should get the same value, right? 0.9535. And the reason why is corr in pandas is equivalent to the Pearson's correlation coefficient. And if you remember what I mentioned in the slides, this is a special case of the Pearson correlation coefficient. So that is why this line of code works. Honestly, pandas makes this a piece of cake. Same with Scipy. But if you're doing a manual, I wouldn't say it's super tedious, but it takes a few lines to code to get the correct answer. So yeah, that's the Point-Biserial correlation coefficient. Hope you guys found a ton of value on this video on the Point-Biserial correlation coefficient. If you did learn something new, make sure to subscribe to the channel. Look, we're trying to hit 100,000 subscribers in 2025, and the only way to do that is by uploading multiple videos every single week. Now, if you want to learn even more about statistics or correlation and coefficients, I have a few videos linked down below that I think you guys would find valuable, and a playlist right over here that I'm still developing.